So, hello, namaskar to the all chemistry lovers, doctors and engineers of the near future. मैं विजय कुमार सोनी वेलकम्स यू इन द केमिस्ट्री वाला चैनल मीन्स आप सभी का मैं हार्दिक स्वागत करता हूं पर्टिकुलर रिगार्डिंग टू द जस्ट केमिस्ट्री. In previous video we have discussed about the just a lot of things regarding to complex compound and especially for the just color in complex compound. Today we will go with the stability of the complex compound. So if we'll go with the just stability of the complex compound, then this is the it will use of stability constant as a you can say ks or beta also, and effectant factors to the stability of the complex compound. So first of all we'll go with the just mean of stability constant. Suppose there is the formation of complex compound as follows. What is that? This is the M plus N as a metal atom, X number of ligand according to just here will formation of M, L, this is the X, and in the form of power it will be plus N. So according to law of active mass, what is that? This is the stability constant, means equilibrium constant, and equilibrium constant will be as a stability constant. So this is the Ks is equals to concentration of product is mlx or plus n, and this is the m plus n, this is the number of ligand will be in the form of power. This is your equation number first, where Ks is equals to stability constant. So if there is as an example, and before taking example we can say stability constant. There is an important numerical also. Stability constant of any complex compound is also inversely proportional to the dissociation constant. If there is more value of stability constant, then it will be less value of the dissociation constant, and if there is more value of dissociation constant, then it will be less value of the stability constant. So stability of that compound will be lesser. If this value increases and its value decreases, then it will be more stability of the complex compound. Now I would like to go just suppose as example there is Cu plus 2. It reacts with the 4 of NH3 to give Cu NH3 whole 4. This is the 2 plus, then Ks will be, this is the Cu NH3 whole 4 2 plus, this is the Cu plus 2, this is your NH3 whole power 4. This is the equation number first. You can say this is the equation second, and this is the equation third. If anybody asks you, can this complex compound form in different steps, then it is yes. As a step it will form as follows. This is the first of all metal atom as a Cu plus 2 reacts with one of the NH3 to give Cu NH3. This is the plus 2, or you can say 2 plus. This is the first step. So it will be stepwise constant also. So stepwise constant is K1 equals to Cu NH3. This is the 2 plus upon just Cu plus 2, and you can say this is your NS3. Now in the second step, this is the first step. Now we'll go with the second step. So second step will be as follows. Second step, one of the just species as a forming species CuNS3 2 plus and one of the another NS3 reacts with each other to give just Cu NS3. This is the whole 2 and this is the 2 plus. Now the value of K2 will be, this is the Cu NS3 whole 2, this is the 2 plus upon, this is your Cu NS3, this is your, you can say 2 plus, this is the 2 plus and one of the NS3. In that case, this will be equation number 4 and this will be equation number 5. This was about the 2 step. We'll go with the 2 further step also, third and fourth. Now regarding to just third step, we'll take the next step over here. What is that? Listen me carefully. So regarding to third step, it will be your K3 equals to, you can say, here is the third step during formation. It will be Cu NS3 whole 2. This is the 2 plus. This is another NS3. NS3. Here will formation of Cu NS3 whole 3 2 plus. Regarding to it, it will be K3 and K3 is your, you can say Cu NS3 whole 3 NS3 whole 3 2 plus and this is the Cu NS3 whole 2 2 plus means concentration of product upon reactant. So it will be your NS3. This is the equation number, you can say 6th. And for K4, just this is the third step. And regarding to fourth step, what will be? Just this is the Cu NS3 whole 3. This is the plus 2 and this is the one of the NS3 gives you Cu NS3 whole 4. This is the 2 plus. Now K4 will be your Cu NS3. This is the Cu NS3 whole 4 2 plus upon, this is the Cu NS3 whole 3 2 plus and NS3. This is your equation number 7. Now the relationship between the just K1, K2, K3, K4 and overall stability constant. So on multiplying to the equation, this is your fourth, fifth, sixth and seventh. What will be? It will as follows. What is that? Listen me carefully. This is your K1 into K2, K1 into K2 into K3 into K4 will be equal to the value of K1 is your, you can say Cu NS3 2 plus upon Cu plus 2. This is your NS3 value of K2. This is the Cu NS3 whole 2. This is the 2 plus upon Cu NS3 just 2 plus and NS3 into value of K3. This is the Cu NS3 whole 3 2 plus upon Cu NS3 whole 2 2 plus and this is the NS3. Now the value of K4, this is the Cu NS3 whole 4 2 plus upon Cu NS3 whole 3 2 plus and NS3. So what may, this step may cancel out by this may cancel out by this may cancel out by this. So overall what will be? It will be K1 into K2 into K3 into K4 will equal to the, just you can say Cu NS3 whole 4 2 plus upon, this is the Cu plus 2 over here, one of the NS3, 2 NS3, 3 and 4. So we can write it as follows: NS3's whole 4. This is the equal to the Ks, or you can say Ks stability constant can be denoted by beta also. So here is the use of 4 ligand. That's why we can say beta 4. This is the relationship between overall stability constant and just stepwise stability constant as a K1, K2, K3 and K4. Now we can say, what we can say that we can say that the stability constant is your as follows. So this is the regarding to stability constant. This is your K1, K2, K1, K2, K3 and K4 are the stepwise stability constant and you can say beta 4 or Ks is your overall stability constant, and that is your as follows. You can say beta 4 or Ks is equals to K1 into K2 into K3 and into K4. This is the final relationship as a, you can say, just equation. It was the 4th, 5th, 6th, 7th and 8. This is the equation number 8. Now we'll go with the stability factors. So these are the factors of, yeah, effectant factors. This is the effectant factors of stability constant. Effectant factors of Ks, or you can say stability of complex compound. Complex compound. What are they? First is, these are as follows. First is your charge density. This is the charge density. Second is your nature of ligand. Third is your chelation. And fourth is your, you can say, size of central metal atom. Size of central metal atom. These are the four effectant factors. If we'll go with the first factor, what is that? I will use of William Irwin law also, because it was discovered by William Irwin, the name of two scientists. So what are they? Just it is your nature of the, just you can say, charge density. So this is the first is your charge density. When this factor can be applied, it is more important. Suppose you have Fe Cn whole 6, this is 4 minus, and another complex is your Fe Cn whole 6, this is the 3 minus. Both exist same central metal atom as Fe, same number of ligand as a Cn 6, but here is the charge 6 minus 4, Fe carries plus 2 charge, and 6 minus 3, Fe carries plus 3 charge. And the value of charge density is equals to, charge density is equals to charge upon radius. This is the charge upon radius. So more value of the charge, more value of the charge density, and more value of charge density, then it will more stability of the complex compound. Stability of complex compound. So what we can say that here is the charge density, number of value of charge is plus 3 and plus 2. So this compound means ferricyanide ion is more stable than the ferrocyanide ion. If you will go with the just 3D series, then elements which forms plus 3 and elements which forms plus 2, then elements which forms plus 3, they forms more stable complex compound than the plus 2 stability, than the plus 2. And if we'll go with the just plus 2, then it will use of William Irwin law. William Irwin law, what is that? They told just the stability for the by just valent central metal atom, the stability factor will be as follows. So this is the Mn, this is the plus 2, Fe plus 2, cobalt plus 2, nickel plus 2, copper plus 2, and zinc plus 2. So the stability sequence will be as follows. So what we can say that if metal atom of the 3D series is in plus 2 state, then the complex of the Zn will be more stable. This was about the first factor. Now the time to discuss about the second factor, that is your nature of ligand. So what is that? This is the second factor, nature of ligand. This is your second factor, nature of ligand. Nature of ligand. For this you can say just complex compound. complex compound having strong ligands, they will more stable than the complex compound having weak ligand. Why? Because of, if there is strong ligands, then it will greater attraction between metal atom and ligand. So strength of coordinate bond will be higher. In that case, stability will also higher. So what we can say that we can take just example also. This is the FeCN whole 6 4 minus, and another is your F6. This is the 4 minus. Both are just a complex of Fe, but you can see Cn is a strong ligand. This is the strong ligand, and F is your weak ligand. This is the weak ligand. So the stability will be higher for the FeCN64 minus. This was regarding to just your second factor. Now I would like to go with the third factor, that is your chelation. We have discussed in previous video also regarding to just ligand also. In that case, in that video we have discussed about the chelation and what is the meaning of chelation. Again I am repeating, chelation means when or bidentate or polydentate ligands attached with metal atom, then they forms a 5 or 6 membered ring structure that is called as chelate ring. This effect is called as chelation. Yeah, property phenomenon, chelation, and compound is called as chelate compound, and ligand is called as chelate ligand. If we'll go with the just example, then we can take just suppose there is the complex compound Co-En whole 3 plus. It is called as tris ethylene diamine, or you can say tris ethane 1,2 diamine cobalt third ion. So what will be? Listen me carefully. It's too important. More chelation, more stability. Means regarding to this effectant factor, it will use of the one of the statement: more chelation, more stability; less chelation, less stability; no chelation, it will be least stability. So here will the formation of ring as follows. This is the cobalt and this is the NS2 ethylene 1,2 diamine. So you can say ethylene diamine, or you can say ethane 1,2 diamine. You can see if nitrogen donates the lone pair, and from this side also, here is the 5 member 1, 2, 3, 4 and 5. This 5 member or 6 member ring is called as chelate ring. In that case, this compound is called as chelate compound, and En is called as chelate ligand, and this property is called as chelation. So we can say that more chelation, it will more stability, and less chelation, it will less stability of the complex compound. So if you will go, suppose this is your as example Fe, yes, you can take Co, this is the Co, En whole 3, this is the 2 plus, or 3 plus. This is the another complex compound CO. You can take N as 3 whole 6 3 plus. Then we can say En is a bidentate ligand and NS3 is a monodentate ligand. So this forms chelate ring. That's why it's a chelate ligand. While this is non-chelate ligand. So if we go with the stability, then first compound will be more stable than the second compound. Now the time to discuss about the final effectant factor, that is size, or you can say atomic radius of the central metal atom. So what is that? Listen me carefully. It's too important. And the final effectant factor. Its final effectant factor, what is that? This is the fourth effectant factor. Size of central metal atom, or you can say radius of the central metal atom, means smaller size, greater attraction on ligands. Here we will use of smaller size of metal atom, it will greater attraction on ligands, and stability of complex compound, this is the complex compound, increases. So what will be, if we'll go with the 3D series, then it's your scandium, titanium, vanadium, chromium, just your manganese, iron, cobalt, nickel, copper, and this is the zinc 30. This is the sequence of size. Size for the metal atom decreases. It will same for the Mn, and here will size, it will decreases, and you can say it will increases. So what will be, here will increase. So the smaller size for the copper is very small. So what we can say that in the 3D series, complex compound of Cu will form as a stable complex compound. This was about the fourth effectant factor. So ये था आपके पास में पर्टिकुलर रिगार्डिंग टू द स्टेबिलिटी कांस्टेंट एंड स्टेबिलिटी फैक्टर्स रिगार्डिंग टू द कॉम्प्लेक्स कंपाउंड. विल मीट इन द नेक्स्ट वीडियो. टिल देन, नमस्कार, शुक्रिया, धन्यवाद.